Hi everyone. Today we are going to learn the lesson Round in Circles, lesson number 1.10. Today we are going to learn why some objects move in circles. Do we know that? It is because of the centripetal force. Wow, look at the image over there. The person, have you played the game in your PE class? How does a ball move in circles? Oh my goodness, it might be because of his strength. No, it is because of the centripetal force. It is a force acting on a particle performing UCM. You might say, teacher, I don't know what is UCM. It's nothing but the uniform circular motion. Let's read it again. It is a force acting on a particle performing uniform circular motion, and this force is along the radius of the circle and directed towards the center of the circle. The word centripetal means center-seeking force. Remember, children, centripetal force is a force acting on a particle performing uniform circular motion, and it acts along the radius. It is acting towards the center of the circle. Let us see some real-life examples. We like to ride in the car when our dad drives it so fast and take twists and turns in the corners. Yes, as a car makes a turn, the force of friction acting upon the turned wheels of the car provides centripetal force required for circular motion. Look at the other image. We might have played with a bucket of water when we were small. As a bucket of water is tied to a string and spun in a circle, the tension force acting upon the bucket provides the centripetal force required for the circular motion. Children, just recall the lesson Earth and Beyond. We studied about the moons, the stars, and the Earth and the other planets. They orbit around the sun. In this, as the moon orbits the Earth, the force of gravity acting upon the moon provides the centripetal force required for the circular motion. Look at here, there are so many images which gives an example of centripetal force around us. Many of us have traveled to London and some of us to Adari Park too. We might have played in the roller coaster or the Barras wheel. Look at the Barras wheel and the roller coaster. Here the centripetal force is provided by the force of friction. And look at our solar system, how beautiful it is. Here the centripetal force is provided by the force of gravity. He's playing with a rock tied to a string. Here the centripetal force is provided by the tension in the wire. Now we should remember from earlier work that motion is always caused by some kind of force. The same is true for circular motion. Centripetal force is any force that causes an object to follow a circular path. Centripetal force tethers the earth and moon to each other. Teacher, I don't know or understand what is meant by tethers. It's nothing but keeps them in orbit. You know what is meant by orbit. It keeps a proper path. Centripetal force is equal on all parts of the earth. Look at the arrow marks. So the earth moves because of its centripetal force. There will be always some factors affecting forces. So we are going to see about the factors affecting the centripetal force. Centripetal force increases if the object is moved faster, or the object's mass is increased, or the radius of the circle is decreased. What? The radius of the circle is decreased? Don't worry. It's nothing but shorter the size of the rope, it moves faster, and more the centripetal force. Longer the rope, less faster it moves, and less the centripetal force. Don't forget to watch the other two videos given along with this